Hi, today we are looking at compound interest. So compound interest is when you invest money, you earn interest on that money, and then the new interest in the next period is then applied to both what you initially invested and the money that you've earned from other interest. Now, we have a couple formulas. This first one is for annual compounding. So if it compounds once a year, which means your interest is calculated once a year. And it is A, which is our total amount, is equal to our principal, which is the amount we invest, times 1 plus our interest rate as a decimal, so our annual interest rate as a decimal, to a power of t. So our first example, we have a principal of 3,350 is invested in a savings account that pays 3.65% interest compounded annually. What is the amount of the investment after 5 years? So first thing I would do is prove this again and write out what information we're given. So first thing we're given is our principal. So we know our principal is 3,350. Next, we're told our interest rate, which for our annual compounding formula is represented by I. So that's 3.65%. Now, just like before, we need to change that into a decimal. So that's 0.0365. And then we're given a time of 8 years. Now we have our formula. A is equal to P times 1 plus I to a power of t. So we'll fill in our information. So we have A is equal to 3,350 times 1 plus 0.0365 to a power of 8. Now with this, it's important to follow BEDMAS. So we need to do our brackets first, then our exponent, then we'll multiply. So we've got A is equal to 3,350 times 1.0365 to a power of 8. So we have A is 3,350 times 1.33215. So just like I mentioned yesterday, it's important for us to keep as many decimals as possible. We'll multiply those two together. And after 8 years, we are left with $4,462.72 in the account. Now, we aren't always going to be dealing with compounding annually. So we have another formula. So if this one works for any compounding period, so our total amount in the account is equal to our principal times 1 plus our interest rate as a decimal over n, which is how many times it compounds in a year. So for example, if it compounds quarterly, that's 4 times a year. If it's monthly, it'd be 12 times a year, weekly, 52 times a year, and then it's to a power of n times t, where t is our amount of years. So for example, we have a principal of 6,250 is invested in a savings account that pays 1.75% interest compounded monthly. Now we want to know what is the amount in the account after 6 years. So we'll read through this again. So we've got our principal is 6,250. We have a rate of 1.75%, but we want to change that to a decimal. So we'll divide by 100. So that's 0.0175. It's compounded monthly, so that's 12 times a year. And our time is 6 years. So writing out our formula, we've got A is equal to P times 1 plus R over N to the power of nt. So this one, once again, important to follow BEDMAS once we fill in our values. So we've got a is equal to 6,250 times 1 plus 0.0175 over 12 to a power of 12 times 6. So in that step, I'll do a couple things. One is I'll do this division, and I will also do this multiplication. So I've got a is equal to 6,250 times 1 plus 0.0175 divided by 12 gives us 0.001458, and then we've got 3's repeating, and then that's to the power of 72. So we've got a is equal to 6,250 times 1.00145833 repeating to the power of 72. So that gives us our amount is equal to 6,250 times 1.110626. And that gives us an amount of $6,941.41. Okay, so we'll do another example with this formula. So we have a principal of $2,200 is invested for 2 years and earns an interest rate, an interest of $196. The interest rate is compounded quarterly. Calculate the annual interest to 1 decimal place. So this kind of combines one of formulas from last class to today's class. So we're given a principal of $2,200. We're given a time of 2 years. We're given the interest earned, which is capital I, so that's from last section, of $196. Now, our interest is compounded quarterly, so our N is equal to 4. And we want to figure out what our rate is. So what I'd first do is use the equation from a previous section of A is equal to P plus I to figure out our amount. So our amount is 2,200 plus 196. So our amount is equal to $2,396. And now we can use our A is equal to P times 1 plus R over N to a power of NT. So we'll fill in the information that we have. So we have 2,396 is equal to 2,200 times 1 plus R over 4 to a power of 4 times 2. So next we need to start moving stuff around to get this on its own. Now when we do that, we're pretty much doing in reverse BEDMAS. So if we can add or subtract anything to the other side, we'll do that first. Then if we can divide or multiply, which is what we'll do now. So we'll divide both sides by 2,200. That gives us 1.0890, and 90 just repeats. So that is equal to 1 plus R over 4 to a power of 8. So I'm just going to rewrite that down here. So we've got 1.0890, for 90 is repeating, equals 1 plus R over 4 to 8. So we now need to get rid of this exponent. So we'll do the opposite operation and take the 8th root of both sides. So that gives us 1.010725 is equal to 1 plus r over 4. We'll then subtract 1 from both sides. So that gives us 0.010725 is equal to r over 4. Multiply both sides by 4. So that gives us 0.0429 equals r. We'll multiply this by 100 to change it from a decimal to a percentage. So we've got 4.29% is our interest rate. Okay, so the other thing we will go over today is what's known as the rule of 72, which is the time in years for an investment to double is given roughly by this formula, where we have 72 divided by our annual interest rate as a percentage. So we don't need to convert it to decimal. We just take 72 and divide it by our interest rate as a percent. So for example, calculate the approximate number of years it will take to double an investment when it earns interest at 5.2% compounded annually. So that's just going to be time is equal to 72 divided by our interest rate of 5.2%. So that gives us 13.8 years.